Good afternoon. Is everyone awake? Perfect. So let me start with a quick 30-second introduction of CraftifAI. We are a startup about 2 years old based out of Bengaluru. We specialize into building AI agents and more particularly AI agents that can automate software development particularly for embedded devices. So covering the complete product portfolio, starting from microcontroller on low-end side till high-end devices like NVIDIA Jetson or and NXP and so on. The key focus is to have more hardware knowledge, integrate more hardware specific aspects of the development into agents. So that's what we do. Before we get into the details, I would like to check how many of you use agentic coders to do your day-to-day job, maybe writing codes. Perfect. And how many of you use this for rows, particularly for rows-based implementation? Perfect. And last question is, how many of you believe that AI agents are ready or going to be ready in near future to generate production-grade codes? Perfect. So we have one person believing it. Awesome. Our core offering is CraftifAI Orbit, which is a multi-agentic workflow. Before we get deeper into it, I would like to go back to where we started. So essentially, it's been 2 years or so since there are a number of generative AI-powered coders that are available in the market, starting with probably most popular one is Cursor. Once there was a time GitHub Copilot was quite popular. And then, of course, there is Lovable, which claim to build applications at much more system level, Devin, etc., etc. Most of them are trained on generic software development problems. And by generic essentially means taking GitHub repos. There's a popular benchmark, SWA bench. A number of them start from there. Ultimately, they go into generic coding problems. And every passing week, they are getting better and better at generating generic codes. But none of them is really approaching to any particular direction in terms of domain-specific code generation. Like you start your project from somewhere, you give a prompt, it will generate some code. Then you realize that the code is missing 10 different pieces. You go back, start debugging, and it seems like it's not your own code. And then the battle starts. So as opposite to what people initially expected, that the gains will be 80 to 90% on the software development. Largely, it's 20 to 30% gain today with respect to generative AI coders. So when we started, we asked a few key questions, particularly how do we build agentic coders which can have more domain-specific knowledge incorporated, so that instead of the coder behaving as a entry-level programmer, it can behave as a seasoned domain-specific programmer. Think of rows. So an entry-level engineer know Python and C, wherever a very seasoned professional know how the structure of the code, how the structure of the rows project looks like, what are different components, etc., etc. So that was one thing. Then second part, in order to really build production grade systems all via prompts and then validate them both in simulation as well as at hardware level, a lot of parameters, a lot of configuration, a lot of setups are required. So the second question that we ask is there a way to effectively build agents which can do that? Then I think as we go more towards demanding performance for robots, real-time performance for different kind of, think of perception pipeline, think of maybe 3D or 4D sensors, and then all working alongside with the motion control libraries, nav2, all libraries are demanding, and there are a lot of aspects that impact the performance. Can we actually design an agent which can evaluate performance on its own, and on top of that, can it utilize the silicon vendor specific coding practices? For example, if you use NVIDIA Jetson, or in Jetson, they have a specific variant of ROS, Isaac ROS, which has its own messaging protocols, its own implementation to get the best performance, essentially keeping the data all onto GPU before the complete processing happens, so that a lot of overheads can be removed. Similarly, if we talk about AMD Creasom, they again have practices how to keep data from moving back and forth between CPU, AI accelerator, and FPGA, etc. So effectively, can we actually design a agent which can utilize vendor-specific aspects? And last, which is very important, second last, is how do we build agents which keep the developers into the loop rather than doing everything autonomously and spitting out the code at the end? Ultimately, embedded people or the people who are building complex systems are very skeptical when it comes to using the technology which they know does not work. And last one is, how do we make this whole workflow reliable that you can actually trust? So keeping all these aspects into mind, we started building CraftifAI agentic ROS. And so the high-level description is, ultimately, it starts with a plain English specification and a simple hardware profile of a robot. Today, the complete workflow is expected to be realized on a single chip. So with that, it starts, then it goes through a series of agentic steps and generates packages, nodes, messages, both custom messages, vendor-specific messages, launch files and parameters, ultimately till the level that it can be integrated into CI/CD, and Docker images can directly be produced just based on the prompts. So overall, we have seen that a number of decent complex apps can be generated within minutes, as opposite to taking days and probably months. Overall for developers, the gain is speed, obviously because of the faster development cycle. Then also repeatability. If we design the agents in such a way that a lot of guardrails are present and a lot of benchmarking is done such that repeatability is possible, then it solves a lot of problem. And lastly, I think portability in terms of targeting different hardware devices. So I'll go to the next slide. On the bottom, you can see the architecture of agentic ROS. It has 5 agents. First one is requirement agent, which specializes into taking inputs. You can give a detailed spec. It clarifies if there is something missing. And eventually, once the performance requirement, the functional requirement, and the design requirement is clear, it generates a structure and passes it on to architect agent. So architect agent has chip level or compute architecture along with the details of how things are structured within the ROS framework. So it takes this and it has a deep search model embedded within it. Using that, it ultimately creates a outline of the solution, a detailed document plus pseudocode plus structure, which is reviewed by the developer and then is passed on to the planner agent. The planner agent understands the SDK structure, the programming model of the chip on which the particular solution is targeted, as well as vendor-specific practices for that given devices. And ultimately, it plans the entire project. It creates package structure. It sets up Qualcomm build, etc. And ultimately, some of the pieces will be used from some existing packages, and a few more will be needed to be created manually. So for manual code writing, we have coder agent, which again have access to vendor-specific API and optimization. It can take the particular coding requirement, and then take the API and the rules which are required to do that, and ultimately writes custom codes. All stitched together is sent to tester agent, which can write unit test based on the input of architect agent's proposal, and then system level test. Tester agent has a system level debugging capabilities, which ultimately can rerun the setup and keep debugging until all the issues are discovered. Overall, the whole workflow is designed in a way that at every step, the user can chat with the system, ask it to explain things which it has generated, and there is a full traceability of the system. So in nutshell, CraftifAI Orbit generates workspace packages, nodes, then message services actions depending upon whether vendor-specific version of ROS is used or the native ROS is used. Then it generates launch file parameters, QoS parameters and settings, TF, and then ultimately simulation setup both for RVig as well as Gazebo. Largely, once it is validated both at simulation and at hardware level, it can generate Docker images and ultimately can natively integrate into CI/CD. These are the key takeaways for the developers. I think most of them are already understood, so I'll go back. This is a demo of a mid-range application, which I'll play. So initially, we take a prompt and create a perception pipeline, which takes input from a camera, run it through for object detection, and generates topics which publish the result of the perception pipeline. Next, we add incrementally one more feature into it by adding a node which can take these topics as input and ultimately implement a motor control algorithm, which is shown in the demo. So would be happy to take any questions at this point of time if you have. That's all from my side.